All right, y'all listen up. Now I'll come around in just a minute and pick up those tests that you're stapling together for me. All right, let's look up here. We're going to go into this week what we call double angles and half angles. Okay. Now these they're twice as fun as normal angles. Um, half angles, nah, they're only half as fun. All right, but double angles and half angles are derived from your sum and difference formulas. So there's the connection to what we've been. We've been on sum and difference formulas for the past couple of weeks. So they're actually derived from these. Now, these are your basically your three double angles. Okay. Now they're over there on the left, and you don't have to memorize these. Okay. If you want to write them down so you have them in your notes, that'll probably be a good idea. Now, so notice the first one, sine 2a is equal to 2 sine A cosine A. So all we're really going to have to do is find those ratios and just fill them in for the double angle for sine. Now, for cosine, cosine's a little bit different here. What you have on cosine is you have three formulas. Okay, there's three of them. It doesn't really matter which one that you use. Okay, so when I'm finding the double angle for cosine, I can use that first formula, I could use that one, or I could use that one. It doesn't matter. Okay, so I'm going to make you a little note over here on the side. You just pick one. Okay, pick one to use. And I tend to like the second one. It's sort of my favorite one to use usually. Okay, we'll talk about maybe sometimes this one might be better as far as that third one. We'll talk about an instance where that might be a little safer. And we probably won't use that first one. Okay. Now, let's see if you picked up something from the formulas. Where are we getting double angle from? The twos, right? What do we, the angle here is A, isn't it? So what are we doing to the angle? We're multiplying the angles by 2, so that's why we call them a double angle. Okay. Now, you have this formula for tangent. Now, you don't really have to write down this tangent one because we're going to do something better. Let's be smart about it. Instead of this one, what can we use instead here? Right. I'm not going to say sine of A over cosine of A, but sine of 2A. Okay. So it's the double angle, sine of 2A over the cosine of 2A. Okay, so you could use this tangent formula, okay, but it's certainly easier if you find the double angle for sine and the double angle for cosine. For tangent, you can just do sine of 2A over cosine 2A. That's all for cosine 2A. So there are three formulas for it. Okay. And now, there again, you don't have to memorize these formulas. But what you're going to have to do in a couple of weeks is you're going to have to recognize these when you see them. Okay. So you don't have to memorize them, but you do have to recognize. So you're going to see this pop up. You're going to see this in a trig equation one day. And you're going to have to remember, hey, that's one of those double angle formulas. Okay, so you're just going to have to be familiar enough that you know it when you see it. Again, you'll have to memorize it, but know them when you see it. All right, y'all got them all written down now? All right, they're on that board to your left if you still need them. Okay. All right. So now let's find some double angles. All right. Now, so the thing is, the directions aren't going to say find the double angles in the triangle. They're going to say this. They're going to find sine 2a, cosine 2a, or not a, but alpha, and then tangent of 2 alpha. Now, what tells me I'm supposed to use double angle formulas? Again, it's the same question I asked earlier. the 2's. Okay, so that's going to give away, hey, they want me to find the double angles. Okay, and I'm given a triangle here to go off of. Now, chances are they probably wouldn't give you the hypotenuse. You'd have to find it by the Pythagorean theorem. Okay, but y'all could do that. Okay, now, so all we're really going to have to do is fill in the 3 formulas. That's it. Okay. Now, what's going to be helpful to fill those formulas in is going to be the sine of alpha and the cosine of alpha. Okay. So by our triangle, let's write up here. All right. What would the sine of alpha be? Yeah, 5 over 13. Okay, and then cosine would be 12 over 13. All right. So let's start off with this first one. Okay, let's do sine 2 alpha. Now, instead of a, we're just using the variable alpha. No big deal. Okay, so instead of 2 sine A cosine A, we'll say 2 sine alpha cosine alpha. And really, it's a lot like those sum and difference formulas. You just fill them in. Okay, so we got 2 times, right now, what we say earlier was sine alpha there. Yeah, 5 over 13. And then the cosine's 12 over 13. Okay, now, some people have trouble with multiplying the fractions. Remember, you multiply the numerators, you multiply the denominators. So on the 2, you really don't have a denominator. Now, if we want to, we could write that as 2 over 1. Okay, so I'm just going to multiply 2 times 5 times 12. So that would be 120. Okay, and now, do the 13s stay the same there? No, you multiply. So 13 times 13 would be 169. If I was adding and subtracting those, they would stay the same. Okay. All right, but there's my double angle for sine. Okay, so sine 2 theta, here's my answer, 120 over 169. Okay, now let's do cosine 2 theta. Let me write my formula here. So cosine of, I said theta, 2 alpha would be equal to, now let's pick a formula. Okay, out of the 3, all right, the second one. I kind of like the second one the best there. All right, so that would be 2 cosine squared alpha. Is it minus 1? Okay, all right. Now we're going to fill this in. Now when we fill in the cosine ratio, we're not going to fill in, well, what was cosine? Cosine was 12 over 13. So we're not going to say 12 over 13 right there. We're going to say 12 over 13 squared. Okay, so you have to square the ratio. That's what cosine squared means. So right now my 2 times. Now, so let's square the cosine ratio. So if I look at the cosine ratio, how do you square a fraction without a calculator? That's a good answer there. You square the numerator, you square the denominator. Okay, so 12 squared would be 144. 13 squared would be 169. So cosine squared would be 144 over 169. Okay, and then we'll bring down minus 1. All right, we got it filled in. Now, order of operations say that we're supposed to multiply first, right, and then subtract. So 2 times 144 over 169. We'll multiply 2 times 144 is 288. 288 over 169. Now, instead of subtracting 1, right, very clever. I'm just going to write like this, because that's the same thing as 1, isn't it? 169 over 169. Why do we want to write it that way? Right, you need common denominators. Okay, so now we can just say, I need some help right here. 288 minus 169. All right, over 169. Okay, so there's my double angle for the cosine. All right, now for tangent, you want to use that? No. Okay, we're going to do what? The sine 2 alpha over cosine 2 alpha. Okay, so for tangent, Okay, we'll just do the sine of 2 alpha over the cosine of 2 alpha. So let's see, the sine was 120 over 169. And then the cosine was 119 over 169. Now we all know what's going to happen there. 169s will cancel. So we'll just get 120 over 119. And truth is, I'm only going to work that first example out the first time there with tangent. For the most part, we can probably do this without any work. We'll just write down the answer for the tangent. Okay, so you don't really have to show all that for the tangent. Now, on your worksheet here, okay, I've got over there underlined for the double angles numbers 4 through 6. I want you to, I want us to do those real quick. Okay, I'm going to put the answers under the document camera so you can check them. Yeah, really. I mean, they're really, really similar because they're derived from. And so really all you're doing is filling in formulas. Okay. Yeah, 4 through 6. Okay, and y'all can kind of glance up here to check them. Now the odd answers are on the back, especially for the rest of the problems that you're going to do kind of later. All the odd answers are on the back. Formula now. Let's look. Let's look at another example here that might be a little bit more complex. Okay. All right, I'm going to do. Hang on. Number 6 was 336 over 527. Nuh-uh. Everything should have been positive there because it was just on a triangle. It wasn't on the coordinate plane. 527. Yeah, 527. What'd you get for cosine? Did you get 527 over 625? Okay, that's probably where you're making a mistake at. Let's look. All right, at number 5. All right, which formula did you use? Call it out to me. The squared. Okay, so let's see. Cosine squared, 24 over 25. 24 squared is 5. All right. And 25 squared is 625. Okay. And now instead of saying -1, we'll say minus 625. Nope. Minus, yeah. What am I thinking there? Okay. 625 over 620. Oh, it is negative, isn't it? Oh, that's what I didn't do. It's 2 times that. Okay. So 2 times that gives you something pretty big there. All right. Okay. We missed the 2. All right. Now, let's look at number 8. Shh, y'all be quiet. Look up. Now, in this case, they just give you this information, and they want you to find all 3 double angles. Once you find sine 2 alpha, or in this case, sine 2 theta, cosine 2 theta, and then tangent of 2 theta. Okay. Now, let's start off with sine 2 theta, since that's part A. Okay, that only has one of them. So sine 2 theta is equal to what was it, 2 sine theta cosine theta, is that right? Is that formula for sine 2 theta? Okay. Now, so I've got sine of theta given to me as 12 over 13, but I'm missing cosine theta. So how am I supposed to find this double angle? Right, you got to draw it out, right? Okay. Now that's why they told you this, so you could draw it out in the correct quadrant. Okay. So that's the idea basically on the rest of these problems is you have to draw the triangle. Okay. Now let's draw the triangle. It's in quadrant 2. Now if something's in quadrant 2, some's going to be negative. All right. Now let's see, sine is 12 over 13. Well, sine is opposite over hypotenuse. So the other leg by the Pythagorean theorem there is going to be 5, and yeah, it would be negative 5. Okay. So now you can tell me what cosine theta is now that you got the triangle. All right. Cosine of theta is negative 5 over 12. Okay. So now that I've got sine of theta and cosine of theta, I can fill in all my double angle formulas. Okay. So let's see. 2 times, all right, sine of theta is 12 over 13. All right, cosine of theta is negative 5 over 12. All right, so let's multiply this out. Let's multiply the numerators. 2 times 12 times negative 5 would be what? Negative 120. Oh, that should be what? 5 over 13. Oops. There we go. And then 13 times 13 now, that gives me 169. All right, now let's do part B, cosine 2 theta. All right, now, in this one, again, let's decide which formula. All right, we're kind of partial to that second one, aren't we? All right, but I'm going to tell you this, the third one would actually be better in this case. Now, all right, that's what I'm going to see if you can figure out. Why would I say, now, in truth, it really doesn't matter, okay? Any of the 3 formulas is going to give you the right answer. But I'm trying to go for the one that's going to be the easiest or the one that I'm less likely to make a mistake on. Now, the second one says 2 cosine squared minus 1. The third one is 1 minus 2 sine squared. So why do you think I'm going to say the third one is actually a better one to kind of go with here? No, not really. Look at the very beginning of the problem. It was given. Sine was given, wasn't it? Okay, so really and truly, I could do that third formula without even having to draw the triangle, couldn't I? So the thing is, if I happen to have missed the cosine ratio, I would still get the double angle for cosine correctly because I would be using what's given instead of what I found. Okay. Now, I could still use any of the 3 formulas that I want to. It's just I always try to play it safe. Okay. So I'm going to use that 1 minus 2 sine squared theta. Okay. Now, y'all help me plug it in here. So let's figure out, all right, what would sine squared give me? Yeah, so there's sine up there. So 144 over 169. Okay. Now we need to multiply before we subtract. So that's going to give me 288 over 169. Now instead of saying 1 minus that, let's change that to 169 over 169. Now help me out. What's 169 minus 288? All right, over 169. Okay. Now for part C, we're just going to write the answer down. Okay, so we're going to use a shortcut. We're just going to do what? Sine over cosine. So there's sine. There's the double angle for sine. There's the double angle for cosine. So sine over cosine. The 169s, what's going to happen there? They're going to cancel. and the negative over the negative is going to make it positive. So it's just going to be 120 over 119. So I'm not even going to show any work for my double angle tangent. Okay. All right, is that okay with everybody? Okay with that? All right, let me look at one more with you, and then I'm going to let you work on the rest of it. All right, I'm going to look at number 12. Okay. All right, they give you this time. What's up with this? They give me cotangent. Yeah, so I'm much better off working with sine or cosine. All right, but they gave me cotangent. So what could I do with that, especially when it comes to drawing my triangle? Right, could we use tangent instead? Okay, so if cotangent is 3, then the tangent would just be 1/3. Okay, and so I know tangent is opposite over adjacent, where I really don't know cotangent. So the same thing would apply if they gave you secant. What would you use? Cosine. If they gave you cosecant, then you would use the sine ratio. All right, let's draw our triangle in the third quadrant so we can get the sine and the cosine, because that's what we need for those formulas. All right, so now let's see what's tangent, opposite over adjacent. So opposite and adjacent. Well, they told me it says in the third quadrant. Okay. Now, one thing about it, if tangent was positive, it would have to be in the third or the first, but it was in the third. Okay, now somebody say something here. And the 1, right? Yeah. So when you get in the third quadrant, both of your legs end up being negative. Okay. All right, now the hypotenuse here, -1 squared would just be 1 plus 3 squared would be 9. So you can get 10. So the hypotenuse would be the square root of 10. Okay. So now we've got an ugly little radical that's reared its head. But don't panic. It's really going to be actually okay. Now, so let's find our double angles. All right, so sine of 2 theta is equal to 2 sine theta cosine theta. Y'all want to write out the sine and cosine theta up here? All right, so sine theta, opposite over hypotenuse, so that would be -1 over square root of 10. And I know that y'all just want to rationalize that so bad you can't hardly stand it, but don't. Okay, don't rationalize. I'll show you why in just a second. Okay, but you're better off actually leaving that so that's not rationalized. Now, if I have to give this as a final answer, I must rationalize it. Okay, but just working with it, I'm not really going to need to rationalize it. You'll see why in just a second. All right, now cosine is going to be -3 over square root of 10. Okay, now let's plug them in. So 2 times sine of theta was -1 over square root of 10 times cosine theta. It's going to be -3 over square root of 10. Now, do you see why I said not to worry about rationalizing? What's going to happen right there? What's going to happen to the radical? Yeah, it's going to go away. Okay, so the square root of 10 times the square root of 10 is just going to give you 10. Okay, and now when you multiply your numerators, 2 times -1 times -3 would be 6. And now that'll reduce, so let's reduce it here. That'll be 3/5. Okay, now on part B, I got to say we just go with the second one. Okay, it doesn't matter. So cosine 2 theta. Let's see, that's 1 minus 2 sine squared. No, we said we were going with the second one, didn't we? Yeah, I just want to go ahead with that one since I wrote it down. Okay, it don't matter. Now, what's going to help me out in this formula right there with it being a radical in there? Squaring them. So when you square those radicals, it's going to undo them. So again, that's why it's really not necessarily to rationalize these ratios. So now let's plug in. We'll say 1 minus 2 times. Now, let's square the sine ratio. So there's the sine ratio. All right, when you square -1, you're just going to get 1. And when you square the square root of 10, it's just going to be 10. Okay, so it'll just be 1 over 10. Okay, now let's multiply before we subtract here. So let's see, 2 times 1/10, 2 times 1 is 2, so it'll be 2/10. Now instead of 1 minus 2/10, let's do 10/10 minus 2/10. So that'll be 8/10, which is 4/5. All right, and I'm not even going to write down the tangent. Let's just say, all right, the tangent is going to be, yeah, 3/4. Okay, but the sine over the cosine, 3/5 over 4/5. You talking about like on the cosine, you use any of the three. Okay, so use whichever one is kind of your favorite. Certainly the first one is kind of sucks, but the second and the third one, usually the ones that you try to use because they're easier to use. Okay, and what we said back on that other example, since sine was given, then we use the third formula because the third formula has sine squared in it. Okay. All in all, it really doesn't matter on your double angle for cosine which formula that you use. All right, did y'all understand the tangent part? Tangent was going to be 3/4. Okay, all right, you got 3 of those problems to do now. All right, y'all can start on those. And the answers to those are all on the back for you.